We're solving problem 15 from the 2023 AIME 2. For each positive integer n, let a sub n be the least positive integer multiple of 23, such that a sub n is congruent to 1 mod 2 to the power of n. Find the number of positive integers n less than or equal to 1,000 that satisfy this right here. So we realize that from the information given, a sub n minus 1, if it's divisible by 2 to the power of n, then a sub n therefore is equal to a sub n minus 1. However, if it is not divisible by 2 to the power of n, then a sub n is equal to a sub n minus 1 plus 23 times 2 to the power of n minus 1. Therefore, we can set a value b sub n that will greatly help us solve this problem. So if we set it, if we let b sub n be equal to a sub n minus 1 over 2, right? Well, then we still can elaborate on b sub n because we can consider if it's divisible by 2 or not, as it is a changing value. So therefore, we can rewrite it as either or b sub n minus 1 over 2, and this is only true if 2 divides b sub n minus 1. However, if it does not divide, then we would have b sub n minus 1 plus 23 over 2. If 2 does not divide b sub n minus 1. So we have these two equations. And note that this equation right here, the one that we want to find values of n for, it only works when b sub n is even, therefore it can be divided by 2. So therefore, with that information, we can start testing out values for b of n to see if there's a recurring pattern, and with these problems there usually is. So we see, this might take a long time, but if you are resilient, you will find that b sub 12 is equal to b sub 1 is equal to 11. Now what this means is that upon listing out values from n is equal to 1 to 12, it will get you a bunch of different numbers, but in the end, after 11 periods, as you could say, the first value and the 12th value are the same. Therefore, this is an 11-period cycle. So this values for b cycle. Then we have n. N, we now know, has to be congruent to the values either 0, 3, 4, or 6 mod 11. From this, from the numbers 0 to 1001, we have 91 numbers, 91 of these sort of like ways to do it. And then we have 4 of these numbers in each group. So we have 364, but we have to subtract 1 because we overcounted by 1 upon getting our final answer. That brings us down to 363, which is the answer for this problem.